Okay, so let's talk about polynomials. What is a polynomial? It really is just a sum of monomials, which that doesn't sound very clear, but what we've been talking about, what we simplified on the last homework, each one of these terms is a monomial. Mono means one. Um, Now you can have a coefficient, right? Some definitions here, like 4x cubed. I would say that 4 is the coefficient of x cubed. So 5 is a coefficient of x squared, 6 is a coefficient of x. um, and so a sum or difference of a bunch of monomials, and we'll expand on exactly what a monomial is for through some of these examples. When we talk about polynomials, um, we want to sometimes classify them. And a typical polynomial where you only have one variable x, we often classify them by their degree. And the degree is the biggest power of x in this case, biggest power of your variable. In this case, that would be x. So if I was to classify this polynomial, I would say that this is a degree 3 polynomial, since 3 is the biggest degree. Degree 3 polynomial. We want to get a little more sophisticated. Degree 3, oftentimes we refer to that as a cubic polynomial. Also, it's kind of customary with polynomials. I could obviously, the order of addition doesn't matter. I could rearrange these terms. I could say this is the same as 5x squared plus 7 plus 4x cubed plus 6x. It's all the same four terms. Typically, when we write a polynomial out, we want to go in order of degrees. So the highest term first, the second highest degree, and then the degree 1 term. And you could refer to this literally as a degree 0. Whenever you have just a number, that's a degree 0 term. Okay, so this next one here doesn't have to be x. If I was to classify this, uh, this is a degree 2 polynomial. Also, a word we use for degree 2, as many of you probably know this, we also refer to this as a quadratic, which is a little misleading. When you think of quad, at least me, I think of 4. But in the world of math, quadratic polynomials are degree 2 polynomials. We also sometimes refer to a polynomial in terms of how many terms it has. And this one has 3 terms, so we could also call this a trinomial. Trinomial. We usually, if that's the end, if there's more than 3 terms, we don't really say something with 4 terms. We don't really have a term for that. We just call it generally a polynomial. So this term could be, this polynomial could be classified in many, many ways. You could just call it a polynomial. You could call it a degree 2 polynomial, a quadratic polynomial. You could call it a trinomial. Those are all ways to describe this polynomial. But again, it's just a sum of a bunch of terms. So here we're taking it down 1. 1/2 z plus 2/3. Z is to the first. So I could call this a degree 1 polynomial. Or I could call this, and usually things that are degree 1, we call them linear, just like a line, a linear polynomial. Going off this in terms of the number of terms, since this only has 2 terms, we could also refer to this as a binomial. And then a lot of times in calculus, it's mostly going to be one variable at a time until you move up into higher level calculus. But sometimes we will have like different multiple variables in there. This is still considered a monomial, and so is this one. And so this would also be a polynomial as well. Let's not worry about the degree. technically, if you had like x cubed times y squared, we would refer to that as a degree 5 term. That's not going to be so important here. I'm not going to worry about that too much. But this would also be considered a polynomial. It's a binomial as well. It has two terms. But yeah, that's about as far as I'd go for that one. Okay, so sticking with the more standard types of polynomials, first thing we'll talk about is adding and subtracting polynomials. So if I have the polynomial or trinomial 5x squared plus x minus 2, and I want to subtract the trinomial x squared plus 3x minus 7, I can do this by distributing first. When you have minus, that means I want to subtract all three of these terms. So it's kind of like distributing a -1. So I would have 5x squared plus x minus 2. And if I distribute this negative sign, because I want to subtract all of those, it's minus x squared minus 3x. Negative times a -7 is plus 7. And then we talk about combining like terms. So like terms are terms that have the same degree, exactly the same. So 5x squared minus x squared. It's like saying if I have 5x squared minus, okay, remember if you don't see a number in front, you can think of that as 1x squared. If I have 5 of these minus one of those, then I have 4 of them. That's 4x squared. So these two are like terms. So that could be combined into 4x squared. Here I have an x to the first and a minus 3x to the first. So these are also like terms. X minus 3x is minus 2x, 1 minus 3. And -2 and positive 7 are both constants. They can be combined as well. So -2 plus 7 gives me plus 5. And again, notice I'm going from highest degree down to lowest degree is the standard way to write it. I also just want to point out, because as we start getting into like algebra stuff, I think a thing that confuses students a lot with algebra is you learn how to do adding, subtracting, multiplying, dividing with numbers. And then when we start throwing in x's, it seems like things are different. And it is true, we're doing it differently. But I want to show you that we really are subtracting the same way you would subtract. For example, let's say I had 987 and I wanted to subtract 243. I can subtract, these are the ones, these are the tens, those are the hundreds. I can subtract 7 minus 3 gives me 4, 8 minus 4 gives me 4, 9 minus 2 gives me 7, and I can get my answer. So another way you could add this, or subtract this, I'm sorry, is if you want to take the polynomial 5x squared plus x minus 2 and subtract x squared plus 3x minus 7, you can do it just like you would with numbers. And so just remember that we're subtracting this whole thing so that when we're going -2, we're going minus -7 means we're really adding 7. There's my plus 5. 1x minus 3x is our minus 2x. 5x squared minus 1x squared is 4x squared. And you can see we get the same answer here. And so I've always wondered why we do it this way instead of like looking more like numbers, how we subtract numbers. But unfortunately, that's kind of the reality. Most of the times books will write it like this. And if you want to, you can make it, turn it into sort of more vertical subtraction like we do with numbers, if you want to. I wish all books did it that way, but I can't control that. Okay, so for this one, okay, adding and subtracting, but we should multiply first. And this is just distributing. We've done this before on a previous homework. So if I distribute this x cubed, what are we going to do with the exponents? I'm going to add those. So we're multiplying. So that's going to give me 2x to the 5th. X cubed times -x is minus x to the 4th. X cubed times +1 is plus x cubed. And then we're going to add. We'll distribute in the 4x squared for this one. Add the exponents. 2 plus 3 is also 5. 4x squared times 5x is 20x cubed. And then 4x squared times -1 is minus 4x squared. And then we'll start to look for like terms here. So 2x to the 5th 4x to the fifth. They have the same degree, so I can add those together and give me 6x to the fifth. I only see one x to the fourth term, so I'll just write that one down. I see x cubed, which is like a 1x cubed plus a 20x cubed. So those are like terms. 1x cubed plus 20x cubed is 21. And then we just have another solo term here, minus 4x squared. So that would be my answer for that. Again, these are the first two examples were typical, but then, just to make sure you can do this for any type of a polynomial. This is just a bunch of terms, but if I wanted to combine them, it is like terms. And, I was talking about degree, but essentially what it has to be is they have to look exactly the same. Like I see 4x to the first, y to the first, 5x to the first, y to the first. Those are identical terms. I'm sorry, not identical. They are like terms. So if I have 4 of those plus 5 of those, I could combine those to make that 9xy. And then negative 3y minus 12y is minus 15y. I see some constants, but usually we put those at the end. So let's go along to here. I have a y squared term, and that's it. So plus y squared. There's a lonely 7x. We'll add that in. And then I can combine my 2, negative 4. 2 minus 4 is negative 2. Plus 8 would give me plus 6. Okay. So adding and subtracting polynomials is fairly straightforward. Multiplying polynomials. So if I have 2x plus 3 times x minus 7, there's lots of different, there's a couple of main techniques for showing how to multiply polynomials. All of them are fine. They're all equivalent. One of them that's, I don't know, maybe not quite as popular anymore, but the old textbooks would call it foiling. Foiling stands for you're going to multiply the first terms together, the first term of each binomial here. So we're going to multiply 2x times x. That's going to give me 2x squared. This stands for the f. Outside means I multiply the two outside terms, the ones on the very end. So that would be 2x times negative 7 is minus 14x. I stands for the inner terms. That's plus 3x. And L stands for the last term. So the last term in each binomial, 3 times negative 7 is negative 21. And then I can combine my like terms. 2x squared, negative 14 plus 3 is minus 11x minus 21. The other common techniques, I know some people do, they call it the box method, where it's really like a grid. If you wanted to do 2x plus 3 times x minus 7, and essentially what you're doing is kind of like finding the area of each one of these squares. So this square is, rectangle is 2x times x, so there's your 2x squared. This one is negative 7 times 2x minus 14x. This is 3 times x. And then for this last one, it's going to be 3 times negative 21. And you see, if you write those all out, you basically get the same thing once you combine the like terms. But I would even say, like I did with the subtraction and addition, that I wish they didn't teach it that way, because that's not how we multiply numbers. Have you ever multiplied, for example, 23 times 47? Does anybody do it horizontally? Does anybody do it foilingly like this? No. Does anybody make a box for that? No. How do we usually multiply 23 times 47 is we line it up vertically, right? And we go 3 times 7 is 21. Carry the 2. 3 times 4 is 12. Plus 2 is 14. 2 times 7 is 14. Of course, we're in the tens place, so we move that over. Add the 1 there. 2 times 4 is 8 plus 1 is 9. And then we start adding these together, right? That's how we usually multiply numbers. So if we're multiplying two binomials, it ought to look the same. And I claim you can do it this way too. This would be the way, if I could reinvent most of the math books, I would probably teach it this way. It's exactly the same as with numbers. So what do we do first? We multiply the -7 by both terms. So -7 times 3 is -21. -7 times 2x is -14x. And then we move over to the second number. We multiply that together. X times 3 is 3x. We're going to bump it over and line it up with the like term. And then x times 2x is 2x squared. And if we add these together, there's our 2x squared. -14 plus 3 is -11x minus 21. In a lot of ways, doesn't that make more sense? Since that's how we multiply numbers. Yes, sadly, a lot of times they don't do it that way. So, but you can if you want. I will, well, I don't really like the box method so much, so I will either be foiling or in some cases, maybe I will multiply vertically. So if you want to pause the video, take a second to multiply this out and maybe even the next one. And then we'll do them together. All right, so for this first one, if I FOIL it out, it means I'm just multiplying x squared times x squared is x to the fourth. Oops. Outer is x squared times 4, so plus 4x squared. The inner, -9x squared. And the last term gives me -36. That's x to the fourth. Combine my middle terms. 4x squared minus 9x squared is minus 5x squared minus 36. Or you could have done it vertically. 4 times 9 is -36. 4 times x squared is 4x squared. X squared times -9 is -9x squared. X squared times x squared is x to the fourth. And you can hopefully see if you add these together, you get the same thing. Okay, same thing here. Try that one on your own. Pause the video. All right, and so you can multiply this out. You can, that's the other thing is foiling. A lot of people call this foiling, but foiling is first, outer, inner, last. But that only works if you have a binomial times a binomial. What would be the inner, right? What do we mean by that? So if you, anyhow, you could still though approach it the same way. So where essentially the concept of foiling is that this 3x is going to get multiplied by each term. So you would have 3x times x squared is 3x cubed. 3x times 5x is 15x squared. 3x times 2 is plus 6x. And then we just have to make sure we distribute the 1 to everybody. So plus 1x squared, which is really just x squared, 1 times 5x, and 1 times 2. And then we'll combine any like terms. I only have one cubic term. I've got a couple of degree 2 terms. 15x squared plus 1x squared is 16x squared. And I've got a couple of linear terms. That's 11x plus 2. And I won't do it, but if you wanted to set it up vertically, you'll see it actually works out really nice. I would probably put the bigger one up above and then the 3x plus 1 here. And if you do the multiplication, you should be able to show that you get the same answer. Okay, one more. So we've been talking about exponents, and we were talking about on the previous one of the previous videos about the distribution law. And you may remember, like if I had, for example, 2x squared y cubed, and I was cubing it, that I can distribute the cube to all three of those. 2 cubed times x squared cubed times y cubed cubed. 2 cubed is 8. Remember, I multiply the exponents, so that would be x to the 6th and y to the 3rd cube. Multiply those, that's y to the 9th. But a major mistake would be to just distribute the cube here. And the reason I can't do that is this was a monomial, right? Everybody's multiplied together. That is one term being cubed. I have to cube everybody, but there are two terms here. You're not allowed to just cube that. If you want to see why, um, try it with a number. Say you had, for example, 2 plus 1 cubed. If you tried to distribute the 2 and go 2 cubed plus 1 cubed, you would get 8 plus 1. You would get an answer of 9. But if you actually combine this, what is this really? This is really 3 cubed. And 3 cubed is not 9. 3 times 3 times 3 is actually 27, right? So that's not right. You don't want to do it that way. You don't want to distribute the cube. Instead, since we're cubing, what does that mean? That means we're going to multiply 2x plus 1 times 2x plus 1 times 2x plus 1. So we are going to multiply together now. Yeah, the best thing to do here would be to multiply 2 of them first. So if we multiply those 2 together, you know what? Might as well do this. So 2x plus 1, 2x plus 1. So 1 times 1 is 1. 1 times 2x is 2x. 2x times 1 is 2x. 2x times 2x is 4x squared. Oops, okay. And if I bring this down, that's 1. Remember here I'm adding when I multiply. 2x plus 2x is 4x. And I have a 4x squared. So these two terms multiply to give me this. So this is the same as 2x plus 1 times 4x squared plus 4x plus 1. And then I could multiply these two polynomials together by either distributing, foiling, so to speak, or doing it with vertical multiplication, which maybe I'll do it that way again since I started it that way. So I'd want to multiply 4x squared plus 4x plus 1 multiplied by 2x plus 1. 1 time each times each of these is going to give me 1 plus 4x plus 4x squared. 2x times 1 is 2x. 2x times 4x is 8x squared. And 2x times 4x squared is 8x cubed. Combining terms, I get 8x cubed plus 12x squared plus 6x plus 1. Okay, last thing with polynomials is dividing. That's unfortunately, that's the worst. Just like with numbers, when you have to divide numbers, division, long division is not fun, but you got to know how to do it. So let's get warmed up actually with numbers. So if I wanted to simplify 521 divided by 3, that's the same as dividing 3 into 521. And let's remember the algorithm. First thing I want to do is ask myself, how many times does 3 go into 5? 1 time. Multiply this down, and then we're going to subtract. 5 minus 3 is 2, and we're just going to bring the other things down. So 2, 2, 1. 1. And then I say, how many times does 3 go into 2? Not really, but how many times does 3 go into 22? 7 times. 7 times 3 is 21. Subtract. That's going to give me 1. Bring this one down. 3 goes into 11. 3 times 3 is 9. Subtract 11 minus 9 is 2. And now it can't go in anymore. So what this is saying is 521 thirds is the same as 173. And the way we could put it is, well, okay, in grade school, you would say remainder 2, right? But we're not going to do that anymore. We would say that it's 173 and 2 thirds, 2 divided by 3. Okay. And so that's how we're going to do it with polynomials, the same way. So we want to divide X squared minus 5x plus 8 divided by x minus 3. Now, of course, it's a little different to say like, well, how many times does this go into this? But the way to think about it is whatever I put here, we know we're going to multiply it by this, bring it down here, and we're going to subtract. And I would at least like to get this x squared to cancel out. So if you think of it that way, what should go here? So when I multiply it by this, I generate an x squared. I should just have an x. Because x times, and I have to multiply it by both terms. So that's going to give me x squared. X squared times minus 3 is minus 3x. And we have to remember we're subtracting both of these. And we'll bring down that 8 after we're done. So x squared minus x squared cancels out. That's 0. But negative 5x minus negative 3x, that means I'm really adding, right? Negative 5 minus negative. I'm really adding 3x, so that's going to give me minus 2x. And then as we do with division, we'll bring that 8 down. Now I can divide one more time. And again, what I'm thinking about in my head is I want to figure out when I put something here and I multiply it by this, I want to get a negative 2x because I want that to subtract out. So then it should just be minus 2. Because that'll give me minus 2x. Minus 2 times negative 3 is plus 6. I'm subtracting both of these, so that's why negative 2x minus negative really means adding. That'll cancel. 8 minus 6 gives me 2. So we could say our answer is, when we do this division, our answer is x minus 2. Now, what did I do with the numbers? I had said, and 2 over x minus 3. What we do with polynomials, though, is we put a plus. And if you go back to what we did up here, isn't it true that 173 and 2/3 is the same thing as 173 plus 2/3? Yeah, it's exactly the same, right? So we're going to write it like that. Okay. Let's try another one. So I want to divide whenever the degree of the top is bigger than the bottom or even equal. I don't know if I have one on the notes here that's equal, but we'll probably practice that in class. So since my degree of the top's bigger than the denominator, we want to simplify this by doing long division. So I want to divide the denominator into the numerator. One thing, really helpful hint when you're doing division is you want to have, notice the numerator is a cubic, but there's a degree 3 term, a degree 1 term, and just a number. There's no degree 2 term, and it's sometimes useful to have a placeholder. I can always think of this as a 0x squared and then plus 7x plus 3. We'll probably see why in a second, why that's kind of useful. So now I want to generate an x cubed here. So if I'm going to multiply it by x squared, I should just have an x. X times this gives me x cubed minus 2x squared plus 2x. Subtract the whole thing. X cubed minus x cubed cancels. 0x squared minus negative 2x squared. That means I'm really going to add I'm going to get positive 2x squared. 7x minus 2x is 5x. Bring down the 3. To generate a 2x squared, I'm just going to put a plus 2. Multiply that. 2x squared minus 4x. 2 times 2 is plus 4. That subtracts out. 5x minus negative 4x is really plus. 3 minus 4 is minus 1. Once this degree is smaller than that, then you're done. So I could say that the quotient here would be, that's x plus 2 plus my remainder over what we were dividing by, x squared minus 2x plus 2. One last one with division. Oh. Doesn't look very bad. It's just, oh, let's get this focused. Come on. Give me a second. I don't really, it's just, I don't really need that really small font here. So let's just see if I can get this to focus. Come on. There. I think that was too small. So I wanted to do x cubed minus 8 divided by x minus 2. And so if you're feeling comfortable, you should pause the video and try to do the long division. You might want to use some placeholders. Try it on your own. Okay, so I want to divide x minus 2 into x cubed plus 0x squared plus 0x and then minus 8. So to generate an x cubed, I'm going to want an x squared term. Multiply it by that, I get x cubed minus 2x squared. Cancels out. 0 minus negative 2x squared is positive 2x squared plus 0x minus 8. To get a 2x squared, multiplying by x, I'm going to need 2x. 2x squared minus 4x. 2x squareds cancel out. 0x minus negative 4x is positive 4x. Bring the negative 8 down. To get a 4x plus 4. 4x minus 8. And notice what happens here. That cancels. Negative 8 minus negative 8 cancels as well. So I get a remainder of 0. And what does that tell you? It tells you, well, it's just like if you're doing 72 divided by 9, you get 8. There is no fraction. It goes in evenly, right? So my answer here is just x squared plus 2x plus 4. There is no remainder on that one. All right. Hopefully this makes sense, and let me know if you have questions.